Solving this, I'll get rid of the parentheses first. 10 plus 4x plus 14x equals 14x minus 35. Well, subtracting 14x from both sides, I'll end up with 10 equals negative 35. That is false, so this is inconsistent. Solving here, first thing to do, remove the parentheses. Negative 6x plus 3 plus 5x equals 3 minus x. Combining like terms, negative x plus 3 equals 3 minus x. Add x to each side. 3 equals 3. Well, that's true, and this turns out to be an identity. So, if you're solving a linear equation that leads to a true statement, such as 0 equals 0, it's an identity, and the solution set is all real numbers. If you're solving a linear equation that leads to a single solution, such as x equals 3, then it's conditional. Usually has a single element for the solution. In solving a linear equation that leads to a false statement, such as negative 3 equals 7, then the equation is an inconsistent equation, and the solution set is the empty set. There is no solution. I did say that equations with a variable in the denominator could be a linear equation. And just like we didn't want to work with the numbers in the denominator, we're not particularly here, and we really do the same thing to solve it. My common denominator here is x minus 4. When I take that times the first fraction, those would cancel out, and I would just end up with a 4. Minus. Now this fraction is over 1. Nothing cancels, so I have to take that negative 2 times x minus 4 equals, here the fraction, the denominator will cancel with my x minus 4, so it just equals 1. So 4 minus 2x plus 8 will equal 1, or negative 2x plus 12 equals 1. Subtract 12 from both sides. Negative 2x equals negative 11, or it turns out x equals 11 halves when I divide both sides by negative 2. Now, one thing I have to do with an equation with the variable in the denominator, since the denominator can never equal 0, it would mean we're dividing by 0, we know already here that x cannot equal 4. And if we came up with a solution of 4 here, we would have to throw that out. This equation, we have to find the common denominator. We got, x squared minus 1. Do you remember your factoring? That factors into x plus 1 times x minus 1. So our common denominator here is x plus 1 times x minus 1. But let's look. X minus 1, that cannot equal 0. So x cannot equal 1, and x cannot equal negative 1, because that would make this first one would make this denominator 0, second would make this denominator 0. So we come up with those solutions, we have to throw them out. The first fraction times our common denominator, the x minus 1s are going to cancel out, and I will take the 3 times the x plus 1 plus the second one, the x plus 1s will cancel out, and I'll take the 2 times the x minus 1. And the third fraction has both x plus 1 and x minus 1, so they both cancel out, and it just equals 5. Remove in parentheses 3x plus 3 plus 2x minus 2 equals 5, or 5x plus 1 equals 5, 5x equals 4, and x equals, dividing both sides by 5, x equals 4/5. Not one of my denominators, the answers I ruled out, so this is a solution. In working this problem, I first have to determine a common denominator. Going to the first denominator, I can factor this, and this is x times x minus 2. The second denominator factors into x minus 2 times x plus 4, and the third denominator is already factored. Because of these factors, I already know that x cannot equal 0, x cannot equal 2, x cannot equal negative 4. That is true because any of those values would make one of these denominators 0, and I cannot have a denominator of 0. Now, to solve the equation, first thing I'm going to do is multiply the entire equation by the lowest common denominator, which is, notice I have the x at x minus 2 from the first denominator. The second denominator, I've already got the x minus 2, so I just need to add the x plus 4. And then that is the last denominator. So looking at the first fraction, x and x minus 2 are already there, so I need to take that numerator, 3 times x plus 4. Plus, I have 2x minus 1. The x minus 2 and x plus 4 would cancel out, so I just have that one times x equals, for the last one, the x plus 4 cancels out, so I'll have 2x times x minus 2. Removing those parentheses, I have 3x plus 12 plus x times these, 2x squared minus x equals 2x squared minus 4x. Getting the x squareds on one side, I'll find they cancel out, so I won't have those. Combining like terms, I have 2x plus 12 equals negative 4x. Subtracting 2x from each side, I'll have 12 equals negative 6x, and x equals negative 2. Now, x equals negative 2 is an okay answer. I cannot have x equal 2, but I can have x equals negative 2.